Hello, my loves. All right, today we are problem solving with volume of solid figures. So our standard is still the same. We're going to relate volume to operations of multiplication and addition, and we're going to solve some real world problems today. Our objective: I can calculate the volume of figures and find missing dimensions when given the volume. Here's your essential question. How do you find the volume of a solid figure? Our lead measures: review volume with Professor Berger, volume problem solving practice, and then those iReady teacher assigned lessons. Again, 2 lessons that I assigned, you need to get those done, and then your 50 minutes for math and 50 minutes for reading.
Hey, I was actually going to go and play with my pet. You know, I love my pet because this is actually a math dog. Do you like math? You see? Okay, gonna down. All right. Hey, actually, this reminds me of an interesting riddle that involves Rich, and I thought maybe we could, all of us together, can look at this one, and then afterwards we might actually go out and play some ball. All right, so let's have some fun with this. So Rich is building a travel crate for his dog, Thomas. This dog, Thomas, is a Beagle mix who is about 28 inches long, 14 inches wide, and 22 inches tall. Real cutie pie. Now, for Thomas to travel safely, his crate needs to be a rectangular prism that is about 12 inches greater than his length and width, and 6 inches greater than his height. So he can fit in there and have some room to kind of play around and be comfortable. Here's the question for us. What is the volume of the travel crate that Rich should build for Thomas? Okay, well, let's think about this. And I think the thing to do here is to take a look at the question and read it carefully. Do you want to read it carefully? Yes, I know you do. Yes. Yeah. Okay, now, let's take a look, for example, at what the length of the crate should be. Well, the length of the crate, so the length is about 12 inches greater than the dog's length, so than Thomas's length. And so what that means is we take a look at Thomas's length, which is 28 inches, and we have to now add 12 inches because that's what it means to be 12 inches greater. So that means that the length will be 28 plus 12 inches. And what is 28 plus 12? But it's just 40 inches. So we see 40 inches is going to be the length of the crate. And similarly, we see that the width also has to be 12 inches greater. 12 inches greater? 12 inches greater, yes, I know. All right, so that means that the width, we have to take 14 inches and now add another 12 inches to make it 12 inches greater. So the width of the crate, we now see is 14 plus 12, which is 26. 26. Okay, now what about the height?
All right, I'm pausing the video because now that you've seen what his thinking process is, I want you to continue thinking along the same lines. I want you to find out, how tall does the shipping crate or does the travel crate need to be? Go ahead and pause this video. Find how tall the travel crate needs to be, and then find the total volume of that travel crate. And then you're going to hit play and check your answer along with Professor Berger and see if you got the same answer that he did.
Well, what we see here is it has to be 6 inches greater, 6 inches greater, 6 inches greater, 6 inches greater than his height, and his height is 22 inches, and so the height of the crate must be 22 plus 6, which we see, in fact, is nothing more than 28. And so actually we now have the dimensions for what the travel crate should look like. The travel crate should look like this. Do you like the travel crate? Do you like it? Yes, you like it? Okay. So we see 40, 28, 26. Now, we want to find the volume of this travel crate. Well, the volume of a rectangular prism of this sort is actually not that very difficult to find, because the volume, in fact, is equal to, I'm going to show you exactly the formula for volume. So volume is equal to the area of the base times the height. And this is...
Okay, do you remember when we first learned about volume? We learned that there's essentially two different formulas, but they really are just the same formula, right? Volume equals base times height. Now, how do you find the base? The base is the length times width, right? The base is really the area of the bottom of the box. And then when you multiply that area times the third dimension, which is the height, that's when we get that volume. That's when we get those cubic units, because we're multiplying 3 dimensions rather than 2. So Professor Berger could say volume equals length times width times height. Or he could use this formula, volume equals base times height.
Where the base area is B, and if L represents the length and W represents the width, then we know what the base area is. It's just length times width. And so really, we could write this volume formula in a cooler way by saying, well, the area of the base is just the length times the width, and then we multiply by the height. And that's the volume for the rectangular prism. Is that right? Do you see that? Do you see that? Yes, I know. We'll be done in a second. Just a second. Almost done. Almost done. Okay, so now let's actually write an equation that's personalized for Thomas. So what do we see? We see that the volume equals, well, the length we see is 40 inches times the width, which we see is 26 inches. 26, you got to write it nicely. 26. So that's the length times the width. So when we multiply that, that's the area of the base. That's that base part. And now if we multiply that by the height, which is 28, that will give us the volume. And so what does this equal? Well, volume will equal, well, first we do inside the parentheses. So 40 times 26, which is 1,040. And we multiply that by 28, and so we see that the volume equals, and this product works out to be 29,120. Now, what are my units? Well, we have inches times inches times inches. So that's actually cubic inches. And so the units here, kind of cool, are cubic inches. I'm just going to write INT, but inches, cubic inches. And that is the answer. So we see that we have a volume of 29,120 cubic inches, and that, in fact, represents the volume of the travel crate for Thomas, because we've now actually found it by, first of all, reading the question and carefully figuring out the dimensions of the travel crate, given the various constraints that are required, and then figuring out the volume, rewriting the volume, and then start plugging things in and solving for the V. And that's it. Isn't that great? It's really wonderful when you can see equations being so useful. Don't you like seeing equations? Yes, yes. Now, do you want to play with the ball? Do you want to catch the ball? Do you want to catch the ball? All right, here we go. Let's see how he does, because he loves chasing the ball. Let's see. Here we go. Whoa, whoa. I forgot I'm holding on to it. All right, have fun with math. I'll see you soon. Woo!
Okay, so we just reviewed volume with Professor Berger, and now let's do some volume problem-solving practice. Get a piece of paper and a pencil so you can solve these problems with me. Mr. Williams' class built this platform for a school event. They also built a model of the platform in which 1 foot was represented by 2 inches. What is the volume of the platform? What is the volume of the model? Ooh, this is more challenging than anything we've done before. This is exciting. Oh, my phone, I'm sorry. Let me put that on silent. Okay. So we need to do 2 things. two things that we have to do. The first thing that we need to do is we need to find out what is, don't know what that came out as. That's supposed to be a 1. We need to find out what is the volume of the platform. All right, well, I have some choices here. I could break my platform up into A, B, and C, or I can break my platform up into A and B. I think I'm going to do it that way. So go ahead and pause the video and give this a try because we've done problems like this before. Give it a try, pause the video, and then come back when you're done and see if your answer matches mine. Okay, so we've got figure A and figure B. Figure A is a length of 3 feet, and the width is going to be 4, and then the height is 2. So the volume for figure A, 3 times 4 is 12, 12 times 2 is 24. Now the volume for B. The length of B is 9, the width is 4, and the height is 2. So I know that 9 times 4 is 36, and now I need to multiply 36 times, whoops, not times 3. Oh, I'm glad I caught that mistake right away. Times 2. And 6 times 2 is 12, and this makes 72. So it's going to be 72 feet cubed. And when we add them together, I'm going to get a total of 8, not 8, Miss Allison, 4, 5, 6, 6, and 9. So it's 96 feet cubed. That's the answer for the first question, 96 cubic feet. But what about question 2? Whoops, sorry. What about question 2? What is the volume of the model? So I need to go back to my problem and look. They also built a model of the platform in which 1 foot is represented, I'm highlighting here. 1 foot is represented by 2 inches. 1 foot is represented by 2 inches. Wow, I've got some thinking to do here. So if 1 foot, whoop, I don't want you. Get back, there we go. If 1 foot equals 2 inches, then what is 2 feet going to equal? It's going to equal 4 inches, right? Because 2 times 2 is 4. What's the 4 feet going to equal in the model? Because now remember, the model is going to be a lot smaller. If it's 4 feet, that means for every foot there's 2 inches. And if I have 1, 2, 3, 4 feet, it's going to be 2, 4, 6, 8 inches because it's 4 times 2. What about this 9 feet? How many inches will that be? Right, 9 times 2 is 18. And what about this 2 over here? 2 times 2 is 4. And how about, don't forget this 3 up here. 3 times 2 is 6. Absolutely. So what we're going to do is we're doing the exact same thing. But in this case, we're talking about the model and not the actual figure. So look back to A. We did the 3 feet, which is going to be 6 inches. And we multiplied it by the 4, which is the depth, and that 4 is 8 inches. And then the height was 2, and we know the height is going to be 4 now. So now we have a whole new problem. 6 times 8, or I can do 6 times 4 times 8. I can do them in any order that I want. I'm going to do 6 times 8, which is 48. And then 48 times 4. Well, you know what? I know that 4 times 8 is 32. And 4 times 4 is 16, 17, 18, 19. So A is going to be 192. Now we're not talking about feet anymore. We're talking about inches cubed. That's going to be figure A. Now, figure B. Same exact shape. It's just that the dimensions have changed slightly. They've only gotten smaller. So instead of this 9, it's going to be 18. And instead of this 4, it's going to be 8. And instead of this 2, it's going to be 4. So now I have a new problem. 18 times 8 times 4. Or I'm going to do this 8 times 4 first, because I know that 8 times 4 is 32. And now I'm going to multiply 18 times 32, and I'm running out of room. I hope you have plenty of room on your paper. Okay. So 18 times 32. 2 times 8 is 16. Regroup, carry that 1 over there. 2 times 1 is 2, plus 1 is 3. So 18 times 2 is 36. But now I need to work with that tens place, so I'm going to put my 0 there. And 3 times 8 is 24, and I'm going to carry the 2 there. 3 times 1 is 3, plus 2 is 5. So all together, for B, I have 576 inches cubed. So what is the volume of the model? 576 inches cubed. Oh, I lost my mouse. Okay, so that was an awful lot of math that we had to do. But we got our answer, and our answer is 96 cubic feet for the regular shape, and 576 cubic inches for the model. Now, why do we have so many inches, but we don't have that many feet? Why is 576 so much bigger than 96? What do you think? Do you remember when we did our conversions? If 1 foot equals 12 inches, that's why we have, the smaller the pieces are, the more that we're going to have, right? Since inches are smaller, we have more inches per foot. Now, here's what you could not have done. You couldn't have tried to cut corners and say, oh, well, this one's 96 and I'm going to multiply 96 times 2. It won't work, because we're not talking about one dimension. It's 3 dimensions. It's the length, the width, and the height. So first we have to multiply the length by 2, then the width by 2, then the height by 2. Okay, so we had to do 2 times 2. We had to do that over and over and over again. Or not 2 times 2, 2 plus 2. So basically what we're doing is we're multiplying 96 times 6. And that's when we're getting that 576 inches. So that's really interesting. But make sure that you do this the right way. Don't try to cut corners and say, oh, I'm just going to do a quick multiply by 2. And you would have gotten the wrong answer. You need to, oh, 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 oh. Did you sing it? All right, let's clear these drawings. And let's go to the next problem. This one was challenging, wasn't it? Let's see what the next one is. Patty added the values of the expressions 2 times 3 times 11 and 2 times 3 times 10 to find the volume of the composite figure. But she made an error. Do you remember this from yesterday? What is the correct volume of the composite figure? Professor Berger solved this problem in his video. Now, I want you to pause this video and find the correct volume of this figure. And then don't forget to press play again so you can check your answer. Okay, so I'm going to cut mine the way Professor Berger did because that was so easy. And in figure A, we have 2 times 3 times 8. And I know that 2 times 3 is 6, and 6 times 8 is 48 centimeters cubed. And then in figure B, very simply, we have 10 times the width of 3, and then the height is over here at 2. I know that 3 times 2 is 6, and 10 times 6 is 60. So A is 48, and B is 60. When I add them up, I get 108 centimeters cubed. Did you get that answer? That's better. 108 centimeters cubed. And it really doesn't matter if you cut it apart the way I did or if you cut it apart the way that Patty did. You'll still get that same answer. All right, let's take a look at this one. As part of a woodworking project, Jordan made the figure at the right, or at the bottom, out of wood building blocks. How much space does the figure he made take up? All right, pause the video and find the answer. How much space? They want to know what is the volume. Okay, I'm going to cut mine. How am I going to cut mine? I'm going to cut mine this way. And the reason I'm cutting it that way is because they gave me this dimension. That's 8 inches. So I'm going to call this figure A, and I'm calling this one figure B. In figure A, the length is 14, and I'll count that one, that 4, as the width, and then the height is going to be 8. Well, I know that 4 times 8 is 32, so 14 times 32. 2 times 4 is 8, and 2 times 1 is 2. Well, that was easy. Now I'm working in my tens place, so I put my tens down there. 3 times 4 is 12, and I regroup. 3 times 1 is 3, plus 1 is 4. Whoops. So all together, I did it again, I'm too close to the edge. I have an 8, a 4, and a 4. So figure A is 448 cubic inches. That's figure A. Now let's find the volume for figure B. Figure B has a length of 8. It has a width, well, let's see, what's this width here? It's the same as this, it's the same as this, and it's the same as this. It's 14 times 3. Now, I could go from left to right and do 8 times 14, and then that answer times 3. Or, using that commutative property, I can say 8 times 3 is 24, and multiply that times 14. 4 times 4 is 16. 4 times 2 is 8, plus 1 is 9. And now we're in the tens place. Let's put our tens there. 1 times 4 is 4. 1 times 2 is 2. And when we add them all up, we've got a 6, 9, 10, 11, 12, 13, and 3. So 336 cubic inches plus 448 cubic inches. We have 12, 13, 14. We have an 8, and we have a 7. So how much space does it take up? 784 cubic inches. That is my answer for Jordan's woodworking project. It took up 784 cubic inches. Did you get that answer? Okay. Wow, we've got a big problem here. Let's take a look at it. On the left, it says the Jade Restaurant has a large aquarium on display in its lobby. The base of the aquarium is 5 feet by 2 feet. The height of the aquarium is 4 feet. How many cubic feet of water are needed to completely fill the aquarium? Okay, so we have an aquarium and we need to completely fill that solid. It's going to be a solid shape, isn't it? Because it's going to be completely filled. Look how messy my aquarium looks. Oh my goodness. Let me clear that. So what is the base? The base of the aquarium is 5 feet by 2 feet. So the base is 10. And we know base, that's supposed to be a B. Base times height is how we get volume. We know the base is 10. What is the height for the Jade Restaurant? The height is 4 feet. So all together, the volume is 40 what? 40 cubic feet. Good. All right. Now, I'm going to read the next problem, and then I want you to pause the video and find the answer to this question, okay? The Pearl Restaurant put a larger aquarium in its lobby. The base of their aquarium is 6 feet by 3 feet, and the height is 4 feet. How many more cubic feet of water does the Pearl Restaurant's aquarium hold than the Jade Restaurant's aquarium? All right, pause the video. And of course, reread that problem as many times as you need to. Draw a quick picture, act it out, do what you need to do to solve this problem, and then hit play again and check your answer with me. All right, so let's see. The base of their aquarium is 6 by 3, which is 18. Their base is 18. And we're multiplying that by 4. Well, I know that 8 times 4 is 32, and 10 times 4 is 40. So 40 plus 32 is 72 cubic feet. Is that the answer you got? Because if that's what your answer is, then you are incorrect. That's not the correct answer. Because what they're asking is, How many more cubic feet of water? How many more cubic feet of water? You do have to know how much this aquarium holds. Yes, you do. But you have to know that because now you need to subtract 72 minus 40. The answer is 32 cubic feet. How many more cubic feet of water do they need? They need 32 more cubic feet. If you got that question right, kiss your brain. If you didn't quite get there, you need to go back and remind yourself how to get there next time. Did you make the mistake and not subtract? Or did you make a mistake with your computations? Did you forget how to multiply length times width times height? If you got them wrong, then I suggest you watch this video again, practice some other things. What you can do is at your house, grab a ruler, grab a tape measure, find a box, measure it, try and find the volume, and then you can use a calculator to check your answers. That's a really cool way to practice this. All right, my loves, get to work. I'll see you next time. I love you. Bye-bye.